Hello, in this video, we are going to prove trigonometric identities. Now, an identity is just an equation which is true for all real numbers. Let me give you a quick example. If you have x plus 5 is equal to 5 plus x, this is an equation which is true for all real numbers because any number that I put on x, this equation is satisfied. Now, a trigonometric identity is just an identity that involves trigonometric functions. Let us start with the most basic or important trigonometric identity, which says sine squared theta plus cos squared theta is equal to 1. The question is, where does this identity come from? Consider a unit circle. A unit circle is just a circle which has radius 1. It's given by the formula x squared plus y squared is equal to 1. Okay, now look at this unit circle and let us draw a right angled triangle. So remember the radius is 1. So this is the center here, 0. So I draw the radius. So this is the radius r, which is equal to 1. Let us drop a perpendicular line from the circumference of the circle to meet the y-axis. So perpendicular meaning we are meeting the x-axis. We are meeting the x-axis at 80 degrees. Let us call the distance from the center to, say, point A. Let us say this B. Let us call the distance from point O to A as x. And let us call the distance from A to B as y. Okay, and let us call the angle subtended by r and x as theta. Now we can use the basic trigonometric ratios to find angle theta using sine function. We say sine theta is equal to opposite. The opposite is y over r. Now remember, r is equal to 1. That is a unit circle. So y divided by r, where r is 1, y divided by 1 will just be y. So this implies that y is equal to sine theta. Remember, we want to prove this basic identity because we are going to use it in most of our lessons. Now, what about cos theta? So you know that cosine is adjacent, so adjacent over hypotenuse, which is r. But r is 1, so x divided by 1 is just x. Therefore, x in this case is cos theta. But remember, we said a unit circle is given by this equation, so we just substitute where there is sine, where there is x, we put sine. So this is just sine squared theta plus cos squared theta is equal to 1. So I want you to note here, the notation is that if you write sine theta squared is just the same as sine squared theta. So there is no difference. So where there is x, I just put sine. Where there is x, I put cos. Okay, I put cos. So this is cos squared, and where there is y, I put sine. So because addition is commutative, so it doesn't matter the order of addition, whether I start with cosine or I start with sine. So this is how we prove this identity, and it is very fundamental in our lesson today. Let us look at a real exam problem. This question says, show that cos squared theta over sine theta plus sine squared theta is equal to 1 minus sine theta divided by sine theta. Okay, so what are we going to do? Okay, so remember, to prove an identity, you have to show that the right hand side is equal to the left hand side, or the left hand side is equal to the right hand side. Depending on the properties that you know, you can move from one side to the other. So that is your choice. If you choose to move from the left to the right, it's okay. If I choose to move from the right to the left, I will still get the same answer. So in this case, we are going to move from the left to the right. Now let us make a note here. So let us make a note here on top here. Remember, we said sine squared theta plus cos squared theta is equal to 1. So let us make cos squared theta as the subject of the formula. So we add cos squared, we subtract sine squared both sides. So this is cos squared theta is equal to, so 1 minus sine squared theta. Okay, so what do we do? Let us write. So I can write cos squared theta over sine theta plus sine squared theta is equal to, this will be 1 minus sine squared theta over sine theta plus sine squared theta. All right. Now remember, 1 minus sine squared theta can be factorized by the difference of two. This will be equal to, I will factorize this because look at this, I have 1 minus sine theta. So I will say this is 1 minus sine theta close, then 1 plus sine theta. When you expand this, you will get what is in the numerator. But I don't forget, I divide by sine theta plus sine squared theta. But remember, sine theta is common, so I can factor out sine theta. And here I remain with 1 plus sine is squared, I remain with 1 sine theta. Okay, so you can see that 1 plus sine theta and 1 plus sine theta is common. Therefore, this becomes, in the numerator, I remain with 1 minus sine theta divided by, in the denominator, I remain with sine theta. Okay, so we are done. Let us look at the second problem. Now, the second problem says, prove that 1 minus cos theta multiplied by 1 plus sec theta or secant theta is equal to sine theta multiplied by tan theta. So I will write a few statements here. I will say recall. So you're going to remember, what are we remembering? We are remembering sec theta. So sec theta is given by what? You should know that this is 1 over cos theta. All right. Number 2, you should remember that tan theta is given by sine theta divided by cos theta. Okay. Again, my disclaimer is that you are not restricted to only one method. This method is what I think is easier for me to work out. Now, I will write the left hand side as 1 minus cos theta, okay, 1 plus, instead of writing sec theta, I will write 1 over cos theta. Okay, so this is 1 over cos theta. All right, now let us expand. So 1 multiplied by 1, I just distribute. So this is 1 multiplied by 1 multiplied by 1 over cos theta is 1 over cos theta. Then I have negative cos theta multiplied by 1. This is negative cos theta. Then negative cos theta multiplied by 1 over cos theta. That is a cancellation because that is a reciprocal. I have negative 1. Okay. Now this is plus 1. This is negative 1. So they cancel. That is a 0. I have 1 over 1 over cos theta minus cos theta over 1. So we can combine this using just simple algebra. So this is equal to, okay. Next, what we have, remember we want sine theta multiplied by tan theta. So I should be able to see a sine somewhere and maybe sine over tan. But what is 1 minus cos squared theta? Okay, we have sine squared theta here. We just make it subject. It will be 1 minus cos squared theta. So instead of writing 1 minus cos squared theta, I just write sine squared theta. Okay, so this is sine squared theta over cos theta. Okay, now what is this? Remember, I can rewrite this as sine theta multiplied by sine theta, right? Because this is squared, then divided by cos theta. Okay, so this is sine theta. We said sine theta over cos theta is tan theta. And this is what we are looking for, and we are done. So again, what is the idea? I looked at this problem and I see that on the right hand side I have sine theta multiplied by tan theta. So I can rewrite the right hand side as sine theta multiplied by sine theta over cos theta. Okay, I can write it in this form. Now I look at the left side. I have 1 minus cos theta, then 1 plus sec theta. I can write secant theta as 1 over cos theta. Then you just expand the brackets using distributive property, then look out what is cancelling, then combine the fraction, and you arrive at that answer. Very good. This is a very exciting flavor. We have the following. This is secant 2 theta is equal to 1 plus tan squared theta divided by 1 minus tan squared theta. So what are we going to do? If you want, you can move from right to left or left to right. So I decide to move from left to right and see what is going to happen. So again, I will say recall. What are we recalling? So you have to follow closely. We have to recall that sec theta is equal to 1 over cos theta. Okay, what does this imply? Remember here we have sec 2 theta. So where there is theta, I just add a 2 before. So this is sec 2 theta is equal to 1 over cos 2 theta. Let us look at cos 2 theta. So what is the idea? we have sec 2 theta, and we have already seen a 2 theta here, but we want a tan to appear somewhere. Now let us look at cos 2 theta. Remember when you have, so this is under recall, that is was 1, then I'll call this maybe 2 star. So we have cos 2 theta can be written as cos theta plus theta. Okay, this you are summing two angles. So theta plus theta is 2 theta. Now let us expand this. So when you expand cosine, remember you have cos theta multiplied by cos theta, right? You just repeat the angle, then you reduce it by sine theta, sine theta. Okay, and what is this? This is very good. So what do we have now? Let us try and put everything together. So in our problem, I'm going to start with sec 2 theta. So second, sec 2 theta is equal to, I first write it as 1 over cos 2 theta. So this is just same as 1 over cos 2 theta, okay, which is equal to, but we said cos 2 theta is equal to cos squared theta minus sine squared theta. So I'll just write 1 over cos squared theta minus sine squared theta. All right. Next thing, we are going to do something here, because we want tan to appear somewhere. Okay. So now remember, this is cos squared theta, right? And you know that sine divided by cos gives tan. Okay, and you have a sine here, you have a cos here, so we can divide throughout by cos squared theta. So let us go ahead and divide what is in the numerator by cos squared theta, and divide what is in the denominator by cos squared theta. So first of all, what I mean is this. So we have cos squared theta, we are going to divide it by, we have cos squared theta minus sine squared theta. So let us divide this by cos squared theta because it is a square. Let us also divide this one by cos squared theta. Okay, what is this? So once again, I want you to remember that. So this is just okay, this is just 1 minus, this is tan squared theta. Now what do we have? So here I will write, so sec 2 theta is equal to, so in the numerator I say 1 divided by, we are dividing throughout by cos squared theta, then divided by, what is in the denominator is cos squared theta minus sine squared theta. And when we divide it by cos squared theta, we get this term here, right? So I will go ahead and write 1 minus tan squared theta, okay? And we have the 1 minus tan squared theta, that is what we're looking for. Now in the numerator, we have 1 over cos squared theta. But what is 1 over cos squared theta? We said it is 1 over cos theta is sec theta. So this will be sec squared theta. So I will write this as sec squared theta divided by 1 minus tan squared theta. Something we need to remember, we said sine squared theta plus cos squared theta is equal to 1. This is what we said. So we have sec squared theta, right, which is 1 over cos, okay? So we can divide this side by cos squared theta so that we have the sec. We do the same here, cos squared theta. We do the same here, cos squared theta. So this gives a 1, right? That gives a 1. This gives a tan, okay? That gives a tan. So this is tan squared theta plus, this is a 1, is equal to, this is sec squared theta, okay? So where there is sec squared theta here, I put tan. So this is just the same as 1 plus tan squared theta, right? We have shown here, divided by 1 minus tan squared theta. But what are we looking for? This is what we were looking for. We wanted to verify that sec 2 theta is equal to 1 plus tan squared theta over 1 minus tan squared theta. So what is the idea once again? So I looked at sec 2 theta and I just manipulate this sec 2 theta to come up with uh, 1 plus tan squared theta divided by 1 minus tan squared theta. All right.